Welcome to UGC lecture series Linear Integrated Circuits. Today we are going to see about IC 555 timer, its functional block diagram as a monostable multivibrator and astable multivibrator. This timer was introduced in the year 1970 by Signetics Corporation and gave the name SENE 555 timer. It is basically a monolithic timing circuit that produces accurate and highly stable time delays and or oscillations. The timer IC is set up to work in either of the two modes, one shot or monostable multivibrator or a free running or a stable multivibrator. These are the important features of 555 timer. It operates from a wide range of power supplies ranging from 5 volts to 18 volts supply voltage. The sinking and sourcing load current is 200 milliamps. The external components should be selected properly so that the timing intervals can be made into several minutes along with the frequencies exceeding the several hundred kilohertz. The output of the 555 timer can drive a transistor logic due to its high current output. It is compatible with TTL logic. The temperature stability of 50 parts per million per degree Celsius change in temperature or equivalently 0.005% per degree Celsius. The duty cycle of the timer is adjustable by having the R and C components. The maximum power dissipation per package is 600 milliwatts and its trigger and reset inputs has logic compatibility. So, it is available in 8-pin dip, or you can see the circular metal can package. In the pin diagram you can see first terminal is ground, second one is for trigger input, and from the third terminal you can take the output of the timer. Fourth is to reset the timer, and fifth one is to use to give control voltage to change the timing cycle. Threshold voltage is at 6th pin and discharge voltage at the 7th pin, and for 8th pin you can give the supply voltage. This is the functional block diagram of 555 IC, in which you can see the upper comparator and the lower comparator, which drives the flip flop or S flip flop, and the Q bar output is taken and given to the input of the inverter. The output of the inverter is the output of the entire circuit 555 timer. So, here the upper and the lower comparator set and reset the flip flops respectively. So, when the voltage at the positive terminal crosses this threshold voltage 1/3 VCC, the lower comparator sets the flip flop. If it sets the flip flop, then Q is high and Q bar is low. So, the operation of the SR flip flop is, if S is equal to 1, then Q will be high, Q bar will be low. So, these outputs are complement to each other. If Q is 1, Q bar is 0, if Q is 0, Q bar is 1. So, if S is 1, Q will set and Q bar will be 0, and this 0 is inverted at the output. And once the signal present at the positive terminal of the upper comparator is higher than this 2/3 VCC, then this reset pin will have a high logic, and if it has high logic, Q bar will be equal to 1, because Q will be 0. So, the complement of Q is Q bar, so which has 1 and which is inverted at the output of the timer. So, in this way the upper and lower comparator set and reset the flip flop, and this makes the output low and high, and this low and high output will be based upon the voltages present at the other terminals of the upper and the lower comparator, since it has already the threshold voltages 2/3 VCC to the upper comparator and 1/3 VCC to the lower comparator from the supply voltage VCC. So, this is the general block diagram of IC 555 timer, and we are going to see about the monostable multivibrator using this 555 timer now. So, the applications of 555 timer as monostable multivibrator, astable multivibrator. It can also be used as a timer oscillator and as a ramp generator. We are going to focus these two topics, monostable multivibrator and astable multivibrator. So, this is the circuit for a monostable multivibrator using 555 timer. We have already discussed about the monostable multivibrator using IC 741 operational amplifier, where we have given a trigger input to the operational amplifier, and the output of the monostable multivibrator will be a pulse, single pulse, and so it is otherwise known as the one shot multivibrator. Similarly, here the same pulse is going to be generated, and that can be used for a time delay for other circuit by using a trigger input signal to the lower comparator, and so it is known as one shot multivibrator here also. So, instead of using IC 741, we are now going to use the 555 timer IC to get the monostable multivibrator operation. So, we have seen just now we have seen the functional diagram of IC 555. Here we have connected two external components. They are the resistor and the capacitor here. This is the these are the two components which are connected externally, and we are giving a trigger pulse to the lower comparator. This is the difference between the previous circuit, that is the functional diagram, and the monostable multivibrator. Now, consider that initially the Q bar is high and the output is low. So, that is the stable state. The output is low because it is a inverting buffer. So, the Q bar will be inverted at the output terminal of 555 timer. So, the lower output says that it is the stable state. So, in that case, if the Q bar is high, then the transistor, this transistor is called as a discharge transistor, since it is connected across a capacitor. So, this discharge transistor is a path for the capacitor to discharge its potential to the ground. So, if the Q bar is high, then this discharge transistor is connected in the circuit. This high state makes the transistor on, and this transistor clamps this capacitor, and it provides the discharge path for the capacitor. Now, the voltage across the capacitor brings to a ground potential due to this discharge transistor, and assume that we are giving a trigger pulse to the lower comparator, and one of the input is the 1/3 VCC for the lower comparator. The DC level of this trigger, which is higher than this 1/3 VCC, which has to be higher than the threshold voltage 1/3 VCC. So, during the negative going of trigger, when it crosses this 1/3 VCC, this lower comparator will be on, will be higher, the output of the lower comparator will have a higher output and sets the flip flop. So, if the flip flop is set, we know that Q is 1. If S is 1, Q is 1, R is 1, Q bar is 1. So, if S is 1, if the lower comparator sets the flip flop, then Q is 1 and Q bar is 0 now. So, during the stable state, Q bar is high and the output is low. Now, once the trigger is present, is provided to the lower comparator, its state, the output of the lower comparator sets the flip flop. If sets the flip flop, then Q bar will be low. If it is low, then the output will be high, and now the timing cycle begins. And if the Q bar is low, then what happens to the discharge transistor? This transistor will be off. It will be off, and so there is no path for the capacitor to make the voltage across the capacitor to 0. There is no discharge path if the transistor is off. So, now the capacitor starts charging towards the supply voltage VCC through the resistor R. So, now this voltage across the capacitor, when it exceeds this 2/3 VCC, here 2/3 VCC is the threshold voltage given to the comparator, upper comparator, or say comparator 1. So, while charging towards the VCC, once the capacitor voltage is just above this 2/3 VCC, then this comparator resets the flip flop. So, R is equal to 1 in that case, and Q bar will be equal to 1, and if it is 1, the output will be 0. So, again the output will go to a stable state, and if it is 1, then the discharge transistor will be connected across the capacitor, and it provides the discharge path for the capacitor's voltage. And now the voltage across the capacitor is instantaneously bring to 0 potential. So, this is the function of a monostable multivibrator. So, initially the output voltage is low, and once the trigger input is given to the lower comparator, the output will be high, and the capacitor will charge towards this VCC. Once the capacitor voltage is crossing this threshold voltage 2/3 VCC of the upper comparator, the flip flop resets and the Q bar will be 1 and the output will be low. So, the time constant of this 555 timer in a monostable multivibrator is due to the externally connected resistor and the capacitor. And we have seen a reset transistor in the functional diagram, which is not shown here. So, this reset transistor, once the reset voltage is given to this transistor, irrespective of the output of the flip flop, this reset transistor will make the output 0. It is high. In this case, the output of the transistor will be high once reset input is given, and the output of the 555 timer will be low. So, here also if you want to reset the entire circuit, you can give the reset input to the reset transistor. Here it will be there in the IC 555 itself. So, to the reset pin you have to give the appropriate potential in order to reset the output voltage. Once you give the reset voltage, then the output will go to 0 state. So, we have discussed about the operation. Now, we have to see the waveforms of the monostable multivibrator. I have discussed about this operation. The output of the voltage, output of the timer will be low before giving the trigger pulse. So, this is said to be the stable state, and if the trigger pulse is given to the second pin, then the output will goes to high state. So, once it is high, then the capacitor will start charging towards this VCC. During charging, it reaches 2/3 VCC, which is the threshold voltage of the upper comparator. So, once it exceeds the 2/3 VCC, here once it exceeds 2/3 VCC, then the upper comparator resets the flip flop. Reset in the sense, then the discharge transistor will be connected across the capacitor. So, instantaneously the capacitor's voltage will get discharged to the ground potential, and similarly at the output the voltage will be 0 or it is low, the output will be in the lower state. So, here 0 voltage, though the maximum voltage is VCC and the minimum voltage is 0 for the output of the timer, and the capacitor's voltage is, it is charging from 0 to 2/3 VCC, and if it reaches 2/3 VCC, instantaneously it discharged to 0 voltage according to the connection present in the monostable multivibrator. So, you have to look at if any negative trigger present here. For example, if there is a series of negative trigger like this, if you have another negative trigger pulse present, then that negative trigger won't be affecting the output voltage, because once it is triggered, the monostable multivibrator is triggered, the capacitor starts charging towards this 2/3 VCC. Once when the capacitor's voltage is 2/3 VCC, when it reaches 2/3 VCC, then only the output will goes to a negative value or a 0 potential, because this is the threshold voltage at the upper comparator. Once the threshold voltage exceeds, then the upper comparator resets. If there is another trigger pulse before this 2/3 VCC, say the time period is t. So, this t. So, once this t elapses, then only the trigger will affect, or the trigger will make the capacitor to charge. Before this t, if any trigger present, a negative trigger present, this won't affect the output of the monostable multivibrator. So, once the capacitor starts charging towards this VCC, and Only when it attains 2 by 3 VCC, until it attains 2 by 3 VCC, there won't be any change in the output. Once it attains 2 by 3 VCC, then only the output will go low, then the capacitor will be discharged instantaneously. And once it reaches 0, then the output will be a stable one. And if it's stable, then if it has any trigger present at the second terminal, and only for that trigger the output reacts, the output goes to a positive value, and the capacitor again starts charging towards this VCC, and once it attains 2 by 3 VCC, it goes to the output goes to low, the capacitor's voltage will immediately brings to 0. So, this is the monostable multivibrators operation. And if I say instead of this negative pulse, if I have a reset pulse here, if I have a reset pulse, if I apply a reset pulse here, then immediately the output will go to negative. That is the importance of the reset input in the timer, in the timer circuit. So, if the negative trigger is present, if any negative trigger is present, as in this case, there is no change in the output, but if a reset pulse is present, then immediately the output goes to low. So, this is the importance of the reset pulse. This is V out, this is VCC. Okay. So, these are the input output waveforms of the monostable multivibrator, and if you want to calculate the time period of the pulse present at the output, then you have to calculate it from the charging time of the capacitor. So, it is Vc is the voltage across the capacitor, and this is charging towards Vcc into 1 minus e power minus t by Rc at t is equal to t. Say this is t, say this is t, not this t. I am talking about the time period of the output waveform. Then your Vc will be equal to, so for this t, your the output, the voltage across the capacitor will be equal to 2 by 3 Vcc. So, substitute here 2 by 3 Vcc is equal to Vcc into 1 minus e power minus capital T by Rc. So, after simplification and taking natural logarithm, then you will get T as 1.1 Rc. This you have to remember while designing the monostable multivibrator using 555 timer. Here these are the two components which we have added in the IC 555 and which decides the time delay of the circuit. And if T is 1 millisecond, this is the design you have got for a monostable multivibrator, then assume C as 0.1 microfarad and calculate R. Then connect these two components and check whether you get the time period of the pulse as 1 millisecond. So, this is the design of the monostable multivibrator also. And next we are going to see about the applications. Just I have listed out the applications of monostable mode in IC using IC 555. It is a missing pulse detector, linear ramp generator, frequency divider and pulse width modulator. The next one is the timer as a astable multivibrator. So, this is the circuit again for the astable multivibrator. So, we have one more resistor in the circuit here. we have only R and C in the case of monostable multivibrator, but in the case of astable multivibrator we have RA and RB. So, the remaining connections are one and the same. The discharge transistor's collector terminal is connected in between the resistors RA and RB, and the remaining connections are one and the same for monostable multivibrator, and there is no trigger present here. For monostable multivibrator, we have given an external input called trigger, and it is a negative trigger, but in the case of astable multivibrator, it is otherwise known as a free running oscillator. Since it is called as an oscillator, there is no external input present at the input terminals of the astable multivibrator. It is going to produce a positive pulse and a negative pulse, pulse high, pulse low, series of these pulses without any input signal. Here the supply, once the supply is given to the circuit, then the capacitor starts charging towards this VCC through the resistors RA and RB. We know that the lower comparator has the threshold voltage 1/3 VCC. So, once the capacitor while charging, it crosses this, just crosses this 1/3 VCC, this comparator is going to set the flip flop. If it sets the flip flop, then Q is equal to the output is taken at Q. Actually, if it is Q bar, then we have to invert the output. If you check with the monostable multivibrator, here we have taken it from Q bar and it is being inverted here by using an inverting buffer, and that is the output of the timer. But in the case of astable multivibrator, it is actually taken from Q. You can also take from this Q bar. You can have the same setup here. From Q bar, if you take, then you have to put an inverting buffer in this case, and the output will be taken. So, if Q bar is low, then the output will be high, and if Q bar is high, the output will be low, since we have a buffer in between the Q bar and the output of the entire circuit. But here it is just a buffer, it is not going to invert it. So, if Q is high, then you will have a high in output. If Q is low, then you will have a low output. Okay. So, once the supply voltage is given as VCC, then the capacitor charges towards this VCC through the resistors RA and RB. And once it crosses this 1/3 VCC, this lower comparator sets the flip flop, and if it sets the flip flop, Q will be high and Q bar will be low. So, you have a high output here. So, previously it is in stable state, and you have a high output here if the capacitor's voltage is just above this 1/3 VCC. And now, if the voltage across the capacitor is just above this 2/3 VCC, just crosses this 2/3 VCC, which is the threshold of the lower comparator, and it resets the flip flop. If it resets the flip flop, then Q bar will be high. In that case only the transistor will be active, the transistor will be on, and this transistor is connected in between the resistor RA RB and to the ground. So, if it is connected, then this transistor is going to produce the discharge path for the capacitor. So, once it is connected in the circuit, then the capacitor's voltage will get discharged through this RB and this transistor Q2. Say this is Q1. This is Q1 and the reset transistor will be called as Q2. So, if Q bar is high, then the transistor is connected in the circuit. Now, the capacitor is discharged towards ground potential through RB, and once it is discharged to 0, so the output in that case Q is low. If Q bar is high, Q is low, and so the output is reduced, output is transited to a lower potential. Once it is discharging, while discharging, the capacitor will cross this 1/3 VCC. which is the threshold of the lower comparator. If it cross, then this output will set the flip flop. If it sets the flip flop, then Q will have a high potential, and so the output will be high. And if it is high, then what happens to the transistor? This transistor, this has a Q bar will be low, so this transistor will be off, and again if it is off, then there is no transistor. Actually, if it is off, then there is no connection here. The transistor will not clamp the capacitor in that case. So, if the transistor is not connected, assumed to be not connected, then the capacitor charges towards this VCC through RA and RB. And if it charges and if it exceeds the threshold voltage present at the upper comparator 2/3 VCC, it resets the flip flop. So, if it resets, then Q is low. So, in this way, during charging, when it crosses this 1/3 VCC, 2/3 VCC, it resets the flip flop, and the output will be 0. And while discharging, the capacitor's voltage will be just exceeding this 1/3 VCC. In that case, it sets the flip flop. If it sets, the output will high. So, in this way, the capacitor charge and discharge between 1/3 VCC and 2/3 VCC, and also the output will have a higher potential, or you can say this is VCC, and you have a T high and T low. So, series of pulses present at the output. So, without any input, the output will have series of pulses. This is because of the charging and discharging of the capacitor, and since you have a resistor RA RB, you can say that this RA will is connected in the circuit in order to not to damage this transistor, discharge transistor, when it is connected, when it is connected across the capacitor. So, this is the function of the astable multivibrator using 555 timer. And how will you calculate the time period of this particular waveform, the output? So, from the capacitors charging and discharging, you have to calculate. This is Vc is equal to, Vc is the capacitor voltage and Vcc is the supply voltage, 1 minus e power minus t by Rc, the same expression. At t is equal to T1, Vc will be 2/3 Vcc, the capacitor voltage will be 2/3 Vcc. Time period I have taken it as T1 and this as T2. So, substitute here, you will have T1 as 1.09 Rc, and at t is equal to T2, Vc will be 1/3 Vcc. So, T2 will be 4.405 Rc. So, T high, from this you have to calculate what is T high. T high is the capacitor's voltage from 1/3 Vcc to 2/3 Vcc. From here, T high is the output is high when the capacitor is charging from 1/3 Vcc to 2/3 Vcc, T1 minus T2, and if you substitute, you will get T high as 0.69 Rc, and here this is while charging. So, the capacitor is charging through Ra and Rb. So, you have to substitute instead of R the summation of two resistors, this is T high, and T low will be discharging period. So, it is 0.69 only through RBC, and the total will be equal to 0.69 into RA plus 2 RB into C. So, this is the time period of astable multivibrator using 555 timer. The applications are function generator, FSK generator and pulse position modulator. These are the applications of the astable mode. Give me the answers. List the applications of 555 timer. Give the other name of monostable multivibrator. How is pulse width in the monostable operation controlled? What is the other name of astable multivibrator? list the applications of a stable multivibrator. So, in this session we have discussed about the timer IC, the functional diagram of the timer IC, using 555 timer, how the monostable operator multivibrator will operate and how a stable multivibrator will work. These are the references. Thank you.